talk a little bit how we've introduced similar projects in the physics department at Heriot Watt and how they've progressed over the past year. So physics sits in the School of Engineering and Physical Sciences, along with mechanical engineering, chemistry, chemical engineering, and electrical, electronic, and computer engineering. The physics degree programs we offer here are physics and mathematical physics are our majority of our students. But we also have energy science and technology, engineering physics, chemical physics, and nanoscience running currently. So we introduced similar projects to mechanical engineering in the academic year 2012-13, just passed. This was enabled by a grant from the Higher Education Academy. The grant allowed us to pay for some staff time, equipment costs, and travel budget. The grant was for industrial-based problem solving, so it was to introduce group problems solving on projects set by industry. These projects are undertaken by our fourth-year students of the MPhys degree, and the MPhys degree is a 5-year degree. The students will work in groups of 3 or 4, and there will be 10 weeks of focused on the project work, plus additional time for writing reports and presentations, but there's 10 weeks specifically on the actual projects. They have timetabled 3-hour slots during that week. For the project, there is supervised lab space available if need be, and also each group has a dedicated academic supervisor offering support to the students. So the project timescales in the first 5 weeks of semester, so beginning in September, students actually undertake individual advanced labs, and these labs can be geared towards the topic of the project, but the students work individually on experiments. And then beginning mid-October, their experimental work will start. This will continue through to mid-February, about week 5 of semester 2. But in the middle of that, in December, the students have to write an interim report, reporting on what they've learnt so far, and also planning their future work for after the Christmas break. At the middle of the second semester, they should have finished their experimental work, but we found this year that the students were very keen, and if things were just starting to get working, they did actually work on past that 5 weeks. And then from then on, it was report writing and presentation. So this year we had 6 projects provided by 4 separate companies. So Celex Galileo, or Celex ES, with the recent name change, provided 2 projects. These were both laser-based projects from the optical group in Celex. Holoxica is a startup company making holograms based in Edinburgh. They also provided 2 projects, which we'll show you a little bit about in a minute or 2. ADROC was a geophysical company who provided a theoretical project for our students, which matched in extremely well with our mathematical and computational physicists. And we also did an interdisciplinary project with Formula Student and the mechanical engineers in Heriot Watt itself. So to give you an idea of the type of projects we run, this is a project from Holoxica, and the students were tasked with creating a 3D mesh of the James Watt statue, which is actually situated outside the main reception of Heriot Watt. They looked at 2 methods of doing this. The first method was to use a structured light onto an object on a rotating table. The image you can see there is a model bust, and the students scanned the bust and were able to pick up features such as the ear and the nose and the eyes. But they decided this wasn't very practical for measuring a statue that was sort of 7 foot tall. So they used a Kinect sensor to do it, and they rotated round the statue with this Kinect sensor, moving around in one take. And then they developed their own computer algorithms using some open source software and things they've written themselves to mesh it all together and come up with a 3D image of the statue. So you can see the 3D image there plus a photograph of the statue as it sits outside Heriot Watt. They also looked at the graving below the statue to show the resolution that they were able to get was about 5 millimeters. On the statue itself, they were able to pick out features such as buttons and facial features. And the outcome from this project is that an A1 hologram of the statue will be commissioned in May, and it will be mounted in the physics department, and it will be illuminated by a separate project, another project that was running this year, to make an LED light source for the hologram. So this has all come together, and hopefully sort of in the beginning of the summer, May time, then we will see a finished product in the physics department at Heriot Watt, which is all very exciting. Another factor we looked at was interdisciplinary working with the mechanical engineers. So to give our students experience of working in teams of varying disciplines and varying different skill sets. And this worked extremely well, and we managed to create sensors to go on a Formula Student car, which is being constructed at the moment. So the documentation the students are asked to provide for the companies, they are asked to provide very detailed lab books. They also asked for an interim report, as well as final reports and group summaries, and they were tasked with constructing a poster of their final work. The lab books, we emphasise the importance of this because they can be passed on to the industrial partner to follow up and for them to see the work the students have managed to undertake, and also for future work which we might continue a project on in future years. Quick overview of the marking scheme to show that we do include the students' documentation in the lab books into the marking scheme to really emphasise the skills that they're gaining there. I said before, the students created posters, and these will actually be shown at the International Conference of Physics Students in August. So this is good display of our work that we've managed to achieve, good advertising for the companies as well as for the students, and allowing the students to get some international exposure. Again, the students have given their views on the benefits of these projects, giving them a better insight into what to expect in the workplace, give them, instead of having very closed-ended projects, very open projects, so they've benefited from the frustrations of projects as well as the elation when they manage to get results out of the projects. We had an industrial advisory board very recently, and the industrial advisors are very impressed with the standard of the work and also the skills that our students have learned out with the physics base. So the team working skills, their communication skills, which will be extremely beneficial to the students when they go for job interviews and into the workplace. So looking forward, a few of our students have received employment or work experience over the summer vacation from these projects. They've used the experience of the projects in job interviews for CERN and for other companies that are looking at over the summer. We have one confirmed project from our current industrial partner. Even though the projects are only just finishing now, they've confirmed that they will be continuing on next year. We were greatly relieved to see we had a mix of experimental and theoretical projects, and some projects which combined both very well. The interdisciplinary project we have could lead on in the future to having a mixture of physics students and mechanical engineering students. And we've set up an online project submission at the webpage at the bottom there, so that companies who are interested can very easily get in touch with us.